Hello audience, today we are going to discuss about the basic operations on the signals and sequences. Now the learning outcomes of this session are, you should be able to know the basic operations on the signals and operations on the dependent and the independent variables and explore various types of operations. Now we have to see what are the dependent variables and independent variables. The independent variable for a signal is the time, either t or n. So the independent variable is the time. The dependent variable is usually the amplitude, which represents either the voltage or the current. So the independent variable is the time, which is either t or n, and the dependent variable is the amplitude, which is representing voltage or current. Now here we are going to see basic operations on the dependent variable. Those operations are addition, subtraction, multiplication, division, and amplitude scaling. Now addition of two signals. So two signals x of t and y of t can be added together to obtain the sum signal, which is x of t plus y of t. So here we have to add the signal x of t with y of t instant by instant or point by point. Now we are going to discuss subtraction of two signals. Similar to the addition, the subtraction signal or the difference signal is x of t minus y of t. To obtain this difference signal, we have to subtract the signal values x of t and y of t instant by instant or point by point. Now we are going to discuss multiplication of two signals. The multiplication signal or the product signal is x of t dot y of t. To obtain this product signal, we have to multiply the signals x of t and y of t point by point or instant by instant at all the signal values. Next, we are going to discuss division of two signals, and the division of the two signals is given by x of t divided by y of t. And again, we have to perform the division operation at each and every instant, instant by instant or point by point. Next, we are going to discuss the amplitude scaling of the signal. The signal x of t can be scaled in amplitude by simply multiplying with the constant k. And the amplitude scaled signal is k into x of t. Now, similarly, addition of the sequences can be represented as x of n plus y of n. Subtraction of two sequences can be represented as x of n minus y of n. Multiplication of two sequences can be represented as x of n dot y of n. And similarly, the division can be represented as x of n by y of n. And the amplitude scaling can be denoted by k into x of n. Now we are going to discuss the operations on the independent variable. This is now time. So we are going to do the operations on the time axis. Whatever the operations on the dependent variable, they were the operations performed on the y-axis. Now this is the operations on the independent variable that will be performed on the x-axis, which is the time axis for the signals. Now first operation is time delay, second is time advance, the third one is time reversal, and the final operation is time scaling. We are going to discuss about time delay. The time delay signal is represented by x of t minus capital T, where this capital T is the time shift factor. To obtain the time delay signal x of t minus capital T, we have to add the shift factor capital T to the time values of the original signal. Since we are adding this shift factor to the time values, the signal will be pushed forward in the time axis. Since the signal is pushed forward in the time axis, the signal which was occurring at a particular time is now going to be delayed by the time factor. Hence, this is called a time delayed signal. Now, next operation is time advance. The time advanced version of the signal is denoted by x of t plus capital T. Now here we have to subtract the time factor, the shift factor capital T from the time values of the original signal. Now since we are subtracting the time shift factor, the signal is now going to be pushed backward. Now since the signal is pushed backward, it means that the signal is time advance. So the signal started earlier. So the signal advance means the signal was pushed backwards. Next, we are going to discuss the operation time reversal. The time reversed signal is denoted by x of minus t. To obtain this time reverse signal, we have to multiply the values of the time with minus 1. And the time reverse signal we can obtain by simply interchanging the positive and negative time values of the original signal. So we have to flip the original signal about the x-axis so that the positive time and negative time values, they have been interchanged. Now the final operation is time scaling. The time scaled version is represented by x of alpha t or x of at, and the factor 1 by alpha is called time scaling factor. Now to obtain the time scaled signal x of alpha t, we have to multiply the time values of x of t by the scaling factor 1 by alpha. So if you had the signal x of 2t, now you have to multiply the time values by 1 by 2. Therefore, the signal will be compressed. Now if we take alpha greater than 1, as just now described, the time scale signal x of alpha t will be compressed signal. Now if you are going to take alpha is less than 1, then the signal will be expanded. Similarly, the time delay sequence, this is for the discrete time, can be denoted as x of n minus k. The time advance sequence can be represented as x of n plus k. The time reversed sequence can be represented as x of minus n. The time scaled sequence can be represented as x of a into n. I want to thank all the audience for patiently hearing the lecture. Thank you for listening.